question. I want to address a couple questions. First of all, somebody, who was it that said, I forget exactly what you said now, but something about I had 5 to 5 the first time, I had 5 to 5 the second time. How did you said that? Jenny, we got just back here. We got 5 to 5, Michael, 5 to 5 the first time, we got 5 to 5 the second time. Is that surprising?
Yes.
I heard yes, I heard no, I heard that's good. I heard one of all 3 possible answers. It either is surprising, or it's not surprising, or it's somewhere between surprising and not surprising. Good. Let's go through and do some ratios here. That's a 4 to 6. That's okay, man. So we got 1, 2, 3, 4, 5, 6 to 4. 1, 2, 3, 4. That was good.
Yes.
6 to 4. That's gold. 4 to 6. We got that. 5 to 5. All of you guys said it was 5 to 5 the second time. I only see 1 so far. So it's 2. 2. I forgot that one over there. 4, 5, 6 to 4. 2 to 8. Oh, you already got that for me? Good.
That's probably the same person.
Who the hell is this? 2 to 8. Marichelle, thank you. I say that in jest completely, of course. Because I like this. I like this. Yeah, I like it that it's an outlier. It's less outlierish than you would think it would be. Gesundheit. Hold that thought. 7 to 3.
Holy cow.
5 to 5. 3 to 7. You're all broken. 5 to 5. Yeah. Oh, 4 to 6. I'm sorry. Who flipped 6? 4 to 6. Got it. 5 to 5. 8 to 2. 5 to 5. 5 to 5. 4 to 6. 7 to 3. 4 to 6. Okay. Compare and contrast what you guys created with what the coins themselves created. How are they the same? How are they the same? Or how are they, I shouldn't say the same. How are they similar? How are they similar?
Between our 2 first.
This is what I made. You guys invent randomness, essentially. I said, you guys pretend you're a coin. And here I said, let the coins do what the coins do. What's similar from here to
They were
here?
mostly 5 to 5s and 4 to 6s, like this one.
So up here we had mostly 5 to 5s and 4 to 6s. Here we also had mostly 5 to 5s and 4 to 6s. I like that. Good. And does that make sense logically in our minds? Why should that? Good. That's a good answer. I'm not sure if it makes sense. Everything you ask is now making it more cloudy. Good. Thank you, Jess. Why might that make sense? Because somebody said it earlier, I thought. Why might it make sense that we're pretty close to 5 heads, 5 tails on our trials? Because assuming the coins are fair coins, it would be 50-50 heads, 50% heads, 50% tails. Cool? Awesome. And so we see quite a bit of that. What are the differences between what you guys did and what these guys did over here? Or what, I shouldn't say these guys, what the coins did. There are 2 major things that are different. One of them might not be as obvious to you as it is to me, only because I was kind of looking for it and it showed up. What's the one thing that jumped out? Go ahead, please.
There's more outliers.
As we're defining outliers, there's further from that 6 to 4 and 4 to 6 and 5 to 5. Yeah, we got an 8 to 2. Got a couple of them, didn't we? Yeah, we had an 8 to 2 over here. It's 2 to 8, an 8 to 2, a 7 to 3, a 3 to 7. Up here, we only had 1. 3 to 7, made a big deal about it. Up here, 3 to 7. But then over here, it's hard to call them outliers anymore when you see them that much. This goes back to that whole how random versus how coincidental versus, wait a minute, if 20 of you flipped coins, which essentially you did, and 4 or 5 of them came up as 3 and 7 and 2 and 8, that's kind of hard to call an outlier, isn't it? What's the definition of an outlier as you're using it right now? When you guys call those outliers, like Marichelle, you said, I'm the outlier. I love that, by the way. When you said that, what did you mean?
I'm outside of the original, like the average.
Okay, good. What you perceive to be average, you're outside of it. Do outliers happen a lot or a little? In general. Why are things called outliers? Because they lie out from the norm, right? Now here, they seem to happen a lot, right, Michael? which makes it hard for me to call an outlier. See, that's what I'm getting at here, is that this doesn't seem, where are they?
Well,
Go ahead,
I
Michael.
guess how much it all happens would be if you consider them an outlier, because you're saying you don't consider that an outlier, but someone else might consider 4 to 6 an outlier.
I'm considering 8 to 2 and 7 to 3 are not that unusual anymore, simply because they happen so much. If they were truly outliers, that means they're unusual. Well, if it happens 20% of the time, that's kind of like saying a blonde person in this room is an outlier. There are 20% blonde people in this room. Would you guys consider it outliers? I don't know, 20% seems like a high percentage, right? 20%, just FYI, 20% is the percentage of births to be induced by the definition of when you induce pregnancies. That doesn't seem like an outlier to me. I mean, it seems like it should be an outlier, but by the biological workings of a woman, 20% is what the hospital's rules on inductions are. So, you're right about the definition of what an outlier is, Michael. I love that, by the way. But you see, just because it happens so much, it's hard for me to call those 7 and 3s and 8 to 2s outliers. You know what I do call an outlier? On both boards, what do I call an outlier? One result I call an outlier on both boards. You know what it is?
3 and 7.
Not 3 and 7.
2 to 8.
Not 2 to 8. It's on both boards. There's one result. There's one result that is very, very hard for me to believe is truly random. Let me come back to that question. I'm getting ahead of myself anyway, because you guys, I love when you're taking this discussion. So I told you there were 2 differences between what was on this board over here, what was on this board over here. You guys nailed one of them. We have more of our quote-unquote outlierish kind of behaviors. I love that. What's the other difference between your guys' actual flipping and your guys trying to be random flipping up here? Josh, what do you see?
One was more of a guess, while the other one was actually doing it.
Absolutely, sir, absolutely. But suppose somebody walking into the room for the first time and just saw these 2 boards. And I said, the front board is from a different sample than the side board. One of the 2 boards was done by students trying to simulate a coin flip in their mind. The other board was done by those who had an actual coin in their hand and were flipping. Do you think a person who was roughly trained in mathematics could identify which one was the coin flip versus the attempted coin flip? So you're saying, yes, certainly, yes. Tell me why and how.
Because I think the fact that everybody thought so logically that it would be half and half, 50-50 on both sides, is not random.
I love what you just said. So let's recycle that comment, because I love it. There's a 50-50 at work, correct? There is a 50-50 at work here. The coin is fair. The coins I gave you were fair. Which means, if we flip them, it's 50-50 heads and tails. The question I have is, what does that mean? What does it mean to have a coin be 50-50?
But each time you flip it has a 50% chance.
But what does that mean? I love what you're saying, Christina. I love what you're saying. I love what you're saying. What I'm trying to get us to the point of doing is being able to explain this idea to your neighbor who's never had a math class before. Because we all know it's 50-50 on a coin, right? But we also know this. I sat in a stat class. My second stat class I ever took as an undergrad. I was about your guys' age in a stat class. Vince Larisha, love you, Vince. He always had food right here at the tip of his mouth. He had a big Fu Manchu mustache, which kept the food there for most of the class. He was adorable. Love you, Vince. And he made this statement once. He made the statement that he was watching his favorite college team through a season. And he always watched the coin flip, because he's a stat geek like me. He always watched the coin flip on his favorite football team. And he noted with some surprise that the team had always gotten tails 12 times in a row for that season. 12 times in a row. Tails, 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 12 times in a row. And then he asked me, but actually the whole class actually, he's like, what's the chance of tails on the next flip? And that's the answer, 50%. Right? And then he made a statement I'll never forget, Vince. He said, but I'd sure bet on heads. And I said, why would you bet on heads if you just said 50%? And he didn't have a good answer. He kind of like changed the subject and rubbed his mustache full of food and kind of went on. But even a PhD statistician is human enough to try to pretend there's a pattern in randomness. It's due. How many of you have heard the story about the little old lady playing the one-armed bandit at the casino? and she's been there all day long, and it's not paying out, it's not paying out, and all of a sudden the line forms around her.
Oh, yeah, they're all
Waiting for her to get up, waiting, because that machine's due, right?
Right.
That's absolute crap.
Yeah.
That is absolute crap. More on that later. So, let's go back to this 50-50 then. So, what does it mean to have a 50% chance of heads when you flip a coin? What does that mean? If it doesn't mean, I don't know what it doesn't mean, what does it mean, what doesn't it mean? I'm kind of confused myself now. Say that again, Pam!
It's random.
Define random!
It could be either or, I don't.
But what's the 50% have? No, I love what you're saying. Just like rolling a die could be either or.
Yeah.
But what does that 50% have to
Does it
do?
just mean there's only two different, there's a head or a tail?
Okay, we're
It's not
getting
like
close
head,
here.
tail, and four other things. Or
Okay,
like a
so-
dice would be 1 and 6.
So a die would be 1 and 6, a card is 1 and 4, if we're talking about suits, we'll deal with all this soon.
Right.
Okay, we're getting damn close.
Okay.
But there's also, hang on a second though, let me make sure I understand. In that case, there's a 50% chance of me getting hit by a car when I ride my bike to work in the morning. Because I either do or I don't.
No.
No!
I'm
just like, no rule.
You
No, but if I ride my bike to work, I either get hit or I don't. That's 2 outcomes. Anya, critique.
We're flipping a solid object that has 2 different sides, so we can either have one of 2 options.
Well, that's the same thing as me getting hit by a car.
No, because there's all kinds of other extraneous.
No.
things.
Hear what I'm saying. I don't think you hear what I'm saying. I either get hit or I don't. Those are, if I break it down that way, those are 2 options. I could either get I could get a flat or I might not. I might get my bike stolen or I might not. Those are both 2 outcomes. I see what you're saying. There are other things that could happen. But if I break it down to just that, I mean, there's other variables on the coin too. It could be 1973, it might not be 1973. It could be a new penny, it could be an old penny. There's all kinds of other ones, but if I break it down to just the event of what shows. I see what you're saying,
We're
but
still kind of in control though, because if you get hit by a car, that's somebody else hitting you.
But I either do or I don't. I'm not saying who controls it or, that's just why I put blinking lights all over my helmet. I love what you're saying, but there are still 2 outcomes. Why is that not 50-50?
Because there's too many variables.
Josh,
Because it depends on if you walk out in front of the car or not.
go, make that more formal.
So you have control over that?
Over what?
Over the fact that you're walking in front of the car and you're not looking both ways, you're being an idiot in the road, then you're gonna get...
He's getting close to it. He's calling you an idiot. That's a good thing. That's a good thing. He's getting damn close.
I didn't call you.
I know you do, Josh. I love it. No, he drives it.
Both are variables, one of them's not a constant.
Okay, that is the key. The key with a coin is both outcomes are equally likely. Sure, there's only 2 outcomes. I either get hit or I don't. But that doesn't mean they're equally likely. Nobody would ever ride their bike if they were. Or crossing the street.
Yeah.
If you cross the street in Oregon, you're either going to get hit or you're not. But it's not equally likely, right? It's not equally likely. They're different probabilities. So there are 2 outcomes, but they're not 50-50. It might be 1090 or 199 or 0.001, 0.999. Still 2 outcomes though. I see what you guys are saying. The other variables might change the numbers, but the numbers themselves are set by something. But they're not the same except in a coin or a die or a deck of cards, all of which I like playing with in class because of that. Thank you guys. Please, Anya.
I was just gonna say, it's just as likely then on the coin that you're gonna get heads versus
It's
tails.
just as likely that you're going to get heads or tails. Thank you. That is the idea with a coin or a 1-armed bandit or a die or a coin. This is the reason these things are used in Vegas. There's a reason these things are used in Vegas because to some level they're predictable. To some level. To some level. Now what level? That's what I'm getting at now. At what level are they predictable? I'm not saying that if you all flip the coin right now. Actually, all flip a coin right now. That's right, it's on the floor somewhere, still count it. I'm out of penny? Damn it. Okay, raise your hands if you got heads. I predict there are between 8 and 12 hands up right now. Ooh, I'm low, 6, damn. Very man I am not. Do it again!
Does it count if it landed on its edge?
Did it land on its edge?
Yeah.
It did? And stayed up?
Yeah.
Hot. Oh, is it leaning against the book though?
What? No, it literally stood up by itself. Like, I don't know how it bounced.
That happens 1 in about 100,000 tries. It can happen. It's interesting you bring that up, because when I analyzed my chickens in 243, there's a 90% chance when you go to the store to buy a chicken that it's a girl, if it's called a girl, pullet. If it's called a pullet, which is a female baby, there's a 90% chance it actually is a baby. They got some kind of sexing mechanism. But there's, for every 1 in 10,000 birds is both male and female. And one of my students said that all the math we talked about in class was out the window because of that 1 in 10,000 chance. So I said, let's reevaluate the math with your 1 in 10,000. And it only changes the overall result by 0.04%. Same as that up on its edge. I think it's badass that it landed on its edge. But it only happens so infrequently we can kind of ignore it. Flip it again though, for sure. Okay, hands up together, heads! I have to take between 8 and 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now notice what happened last time. 6 the first time, 12 that time. Right? I predicted between 8 and 12. 8 and 12. We were a little bit low on the 1, then a little bit high. What does that have to do with what we're looking at up here? Oh, what does the average have to do with my question of what the 50% means? Because what does the 50% mean? What does it mean, Amy?
To me, it means 1/2 maintenance percentage.
Good for you. That's good. If we were to flip 100,000 coins, at that point, roughly half of them are going to be heads, half are going to be tails. Then if we flip the remainder half and half, and then the remainder half and half, and the remainder half and half. It was noisy, but it was good. I like that. Very, very good. Thank you. Maintenance, tying it back to exponential modeling. Good. Anya?
It means you're just as likely to get heads as you are tails.
Perfect. So apply that to the two boards. How could someone walking in this room know this was you guys faking a coin flip, and this was actually the coin flips happening? They could, if they knew what they were looking for. And I'm going to show you something. Oh, Brittany, go ahead.
Well, I was just wondering if it's because this is too perfect.
Say it.
Almost perfect.
It's too perfect. There's a way of look. Thank you for saying that. Now, the way you said it was actually perfect. It's too 50-50. The idea of 50-50 means, remember what Amy just said? It's the maintenance percentage. It applies to essentially an infinite number of trials. Now, infinite could just mean large, many trials. 1,000,000, 1,000, 100 even. But 10 is a very, 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 very small number of trials. Do you know what the probability is? If you flipped a coin 10 times, what the chance is that you should get a 50-50 result?
1 in a million.
It's not that small. Michael's actually doing very, very neat empirical calculation of what it should be. He's counting up all the times it happened, and then he's going to divide that by the total. 1, 2, 3, 4, 5, 6, 7 out of 21. That's 1 in 3. That's roughly 33% of your trials. It should be about 25%, which means you're pretty damn close. Now, why is it so low? It seems like that should be the most common outcome. And the answer is, it is the most common outcome. 25% is the most common of all of the results. Now, here's the goofy part. That includes Anya's result of heads, 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 tails, 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 tails. That is included in the half heads and half tails. This is regardless of order. It doesn't matter how the heads and tails come. It just means that at the end of the day, you've got 5 heads and 5 tails. And they start breaking off from there. Once the computer's all rocked up, we can show you the curve that goes with them. So, where is the 50-50 then? Michael, go.
The 50-50 is where there's a 3 and 7 and a 7-3 and an 8 and 2 and a 2 and 8.
What Michael's doing, he's looking at the entire set of values. Thank you, sir. Look more macro for 50-50. Look more macro. You have to look essentially at every coin that's ever been flipped and realize this is just a small snapshot of that. And what Michael just did was he said, there's a 7 and 3, there's a 3 and 7. They pair off and make a 5 and 5. There's a more macro, less micro look. And this is a problem with us being humans. When I look at your guys' work, it's freaking awesome. But it's so perfect. Did you notice this? I don't know if anybody noticed this or not. The first person I looked at was writing their stuff on the board up here. 3 tails in a row, 3 heads in a row, 3 tails in a row, 4 heads, 3 heads, 3 heads. Look up at the front board and locate all the 3s and 4s of a kinds that we can see. Let's go find some. Let's go find some. I know they exist, because I did see them up there. Okay, there's 3 heads. There's 3 heads.
There's 3 tails.
4 tails. 3 heads. But you see, 3 tails. Did you see? Woo! Did you see how many more I had in the first two here, though? And how they're spread out more here? There's 3 tails right there. I'm actually impressed you guys had this many, believe it or not. None there. None there. I love this one. Tails, tails, heads, heads, tails, tails. I love that. I love that. It's great. It proves the point. Now, Anya, of course.
Mine's best.
It's kind of hard to believe that heads, 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 tails, 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 tails. The reason I called hers an outlier, there is a 25% chance of getting 5 heads and 5 tails. There is a, what is 2 to the 10th power? It's about 1,000. There's a 1 in 500 chance of getting 5 in a row followed by 5 in a row.
It could happen.
Of course it could. 1 every 500 times. Which is less, much less than 1 in 4. That's why, Brittany, when you said 1 in a million, I'm like, well, it's not quite that unusual. I mean, it shouldn't be that unusual because there's only 1,000 or so results for every one of you guys. It could happen. Of course it could. And you're going to hear me start saying this over the next 4 weeks. Sure, it's possible. It's just not probable. Very good. Probable. Yes, it's possible, but not probable. So do you see what I'm not seeing up here as I scan through here? I'm not seeing those 3s in a row, or 4s, or, well, except for I use 5s. Quite nice, quite nice. Do we have any 5s over here?
6.
Do you see a 6 in a row? Holy hell! That was me. Who was that? What you said something? That was me. That's a good. There's randomness. It's beautiful. Any other ones? FYI, just so you know, there's a 96% chance that you should have at least 1 run of 6 or more if you flip a coin this many times. If you flip a coin this many times. Now, what we haven't been doing, we haven't been paying attention to the around the corner heads and tails. For example, if you look back at this first one right here, technically speaking, I had you put them all on the board because I wanted you to treat them as one big data set. Look what happens if you glue this one to that one. Tails, 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 tails. There's 6 more. Tails, tails, tails. There's 3. Heads, heads. Tails, 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 tails. Now, of course, we're also going to get some up there. But if we glue them up there, because you guys yourselves didn't put a whole lot of 4s or more up there, we're not going to see a whole lot of that track down. Now, we do get a 7. Oh, no, we don't. Because you went heads then tails, not tails then heads, Anya. And I keep referring back to Anya as the outlier. She's the only one I truly call an outlier up there. Because of that is, Brittany, too perfect. That's over the top too perfect. Over the top, it's too predictable. Too predictable. It's applying the 50% literally. Of course, nobody went heads, tails, heads, tails, heads, tails, heads, tails, heads, tails, did you? That would be too micro, wouldn't it? And assuming the coin wouldn't flip the same thing twice in a row. And that's what I want to look at today after we take our 5. I want to see what happens when we flip coins over time. When we get repeats, these clumps. I like to say that randomness clumps because it does. There's a lot more clumping happening over in the random ones, right? There's a lot more clumping happening. Not that clumping doesn't happen up here, it does. It just happens a lot more over here. I want to see if there's some predictability in the clumping of randomness. I was talking to my buddy Doug, the one that just switched classes with us on the way down here. He was talking to him about randomness. He's like, well, it's random. I'm like, yes, of course it's random. That's the. What can you get? And I'm like, you can analyze a result that has just happened and see if it's random enough. That's how somebody that understood what random behavior looks like could walk in here and realize this doesn't look as random as this. It's not clumpy enough. It's too fine-coned, if you will. Does that make sense? Maybe-ish, getting there. Let's take 5. Jory, go ahead.
Well, I was going to say, it's kind of like, for Halloween I was a Dalmatian, so I tried to glue dots on my dress, and I was so OCD about
making them perfect.
Because these spots have to be perfect, and that's
yes.
why I'm like, I look like a cow.
Well, that's funny. But I wonder, has anybody ever looked into Dalmatian?
Yeah.
Are they clumped? Is there? I don't know. Is genetics random like that?
They are clumped. Like I ended up looking up pictures because
you
couldn't
did.
do it. I just couldn't do it. I had to look up pictures.
I need a template to work off of.
I had to do it because I literally spent like 2 hours rearranging the spots.
Oh, that's
on the
adorable.
dress
That's
because
adorable.
I could not do it randomly.
That's so funny.
Yeah.
Well, I'm sorry for any anguish that caused you. Maybe we should have waited for this lesson to have Halloween. All right, take.